Bismillahirrahmanirrahim and Assalamu alaikum. I welcome you all to the lecture number 15 of electric circuit analysis. Today we are going to study the series and parallel capacitors in a circuit and how can we take a sum up or take equivalent of the capacitances to reduce the circuit and therefore reduce the complexity of the given network in any problem. So whenever we have capacitors in parallel, the equivalent is taken as the sum of all the individual capacitors in the network. For example, here we have a network which is powered by a current source I, and we have C1, C2, C3 up till Cn, n number of capacitors which are all in parallel to each other. So the equivalent can be taken as a sum. The C equivalent would be the sum of all the capacitances present in parallel in the circuit. So this is how we take the equivalent when capacitances or capacitors are in parallel. Whereas when capacitors are in series, that is in this network, n number of capacitors are being powered by a voltage source V. So when we have to simplify and reduce the circuit to a C equivalent, what we do is we take the reciprocal of the capacitors. So it will be 1 over C equivalent is equal to reciprocal of C1 plus reciprocal of C2, and if we have further more capacitors, we take the reciprocal of each of the capacitors. So this is how we take the equivalent capacitors, and this is how C equivalent is C1 C2 divided by C1 plus C2. We took the whole reciprocal of this equation. In order to further understand this concept of series and parallel, we will try to attempt example number 6.5. Here we have a number of capacitors between the terminals A and B, and we have to find the equivalent capacitance that is provided to terminals A and B. So first of all, when we look at the circuit, we see that these two are in series. So by taking series equivalent of this 20 microfarad and 5 microfarad, we get to know that the equivalent by following all these steps, which is simple mathematics, we get to know that C equivalent one is 4 microfarad. Now we replace that the combination of 20 and 5 with 4 microfarad, and the remaining circuit is the same. Now you can see that these two capacitors, actually these three capacitors, 4 microfarad, 6 microfarad and 20 microfarad, are all in parallel to each other, and you know that the equivalent capacitance of these three will be the sum of all of these three, that is 4 plus 6 plus 20 would be the equivalent capacitors up till this terminals. So this comes up to 30 microfarad. Now we replace these three capacitors with their equivalent, which is 30 microfarad, and you can see that between terminals A and B, these two are in series to each other. So now we take the series equivalent of this 30 microfarad and 60 microfarad, and we get to know that the equivalent capacitance is 20 microfarad at the terminals A and B. This was simple mathematics. Each step was done for you. Now we move on to solving practice problem number 6.6, which is more or less relevant to the example 6.6. Now we have to find the equivalent capacitance at these two terminals, and this is the network that we are given. So by looking at the circuit, you can see that these two are in parallel, and whenever capacitors are in parallel, you take the sum of the individual capacitors, and these two are in series. So I'll solve them step by step, and by taking the parallel equivalent of this 50 microfarad and 70 microfarad, I get to know that this is 120 microfarad. Now I replace the parallel combination by the equivalent capacitance, which I just found as 120 microfarad, and this is what the network is. Now we take the series combination of the 60 microfarad and 120 microfarad, which comes up to 40 microfarad. Now the resultant circuit by integrating this 40 microfarad is this. Now you can see that this C equivalent 2, which is 40 microfarad, is in parallel to this 20 microfarad. Taking the parallel equivalent, which will be the sum of these two, will become 60 microfarad, and now I'll replace the two parallel combination by 60 microfarad. Now finally you get to know that we get to see that this 120 microfarad and 60 microfarad are in series to each other. So we'll take the series equivalent, which is reciprocal of the net is equal to the reciprocal of each of the capacitors. So this is how we get to know that the C equivalent finally is 40 microfarad. So this is a very simple topic. Equivalent while capacitors are in series and parallel combination. Exercise section 6.3 is related to this part, and you can please solve some questions from chapter number 6, section 6.3, and if in case you have any problems, please do let me know in the question answer session. Thank you very much. Take care. Best of luck.